Okay. Yeah. So let me remove this program. Let me start the new program again. So here the program name is given, base address is given. Let me add this program. In this program, we are going to insert the instruction sequence of instructions which can perform the indirect addressing to access the memory location. Indirect addressing to access this memory location. Let me just select this on top of this. So on memory, there are only two operations, read operation and write operation. Now the data memory is empty. No data is there in the data field of this data memory. So now let me just set the registers also to 0, okay? And okay. So in this activity, there are circumstances which make direct addressing unsuitable and inflexible method to use. So in that case, the many programmers use the indirect addressing mode. So in these cases, the indirect addressing is a more suitable and flexible method to use. So in indirect addressing, the address of the memory location is not directly included in the instruction, but is stored in the general purpose registers here. So let us see this with an example. Let me create a label to understand. Okay. Let me create a loop. So let me go to new label. Let me give the name to this label as like label 2. Okay, and let me add this for looping purpose. Then let me try to move the value, suppose 16, into, so this 16 is the memory location, into a general purpose register. Let me use R0 register. Let me add this instruction. So then let me try to create another instruction, move instruction, where I would like to, move the value, the data. First one is the address, second one is the data. So what is the data? Let me use the data in the hexadecimal, that is the character A is 41 into the another register, suppose register 1, okay, and create a new instruction. So then let me create another loop point, write the label 3, okay, and let me add this label to the memory, the instruction memory. So these are the read operation, move or the read operation. Let me write the instruction for write operation, that is store byte. Let me store a byte of data which is there in the R1 register. In R1 register, whatever the data is stored. So let us try to move that data or write that data back into the memory. So which memory? Let me write that memory is in R0 register. So let me select the register here R0. So that creates that, write the character A, which is there in R0 register, into a memory location where R0 is having the address, memory location address. So here the instruction is using the symbol at. Okay. So then add a character. Let me try to write a simple add operation to add another data into the memory. Okay. So add 1 to the register R0. So that moves to the next byte. That moves to the next byte in the data memory. Add R0, 1 byte to the R0, where R0 initially having the memory location 16. By adding 1, it goes to 17. Then in that location, add the data. Okay. So add the data, that is B, another character, okay, into the register or 1 here in my example. Okay. So let me add that instruction. So then let me use the comparison operation that try to compare the value. Okay. So by just giving the hexadecimal, let me give the hexadecimal value, comparing the data. So that is in the form of a hexa with, sorry, let me remove this. Oh, sorry. Yeah. The value with the next value like h of f. Okay. And then just comparing this value with the character which is there in R1 register. And this will continue for that, creating a loop. So jump not equals to, okay, that is, where is it? Let me go up. Jump not equals to the level 3. When this condition fails, then go to the level 3 for executing. So let me select the level 3 value, okay, to create a loop. And then if I try to execute this, the first character which is going to store at location 16, the first character is A, next character will be B, next is C, next is D. So that will continue until it reach to this condition satisfies. So just look at here while I start running this, you just observe what how the characters, the data is going to write into this data memory. So this is indirect addressing mode, because the address is not directly given into the instruction. It is not given into the instruction. It is indirect addressing mode. So just observe this, how the data is going to be loaded here. Let me run this. See how the data will be updated one by one. See how the bytes are changing here.
Yes.
8, 9, then it is changing 10. 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. So it is trying to read the data. So now it is trying to write the data for these characters A, B, C, D, E, F. Okay. So from this memory location, you start observing how the data will be write into data field. So in this loop, you can observe trying to access the data from the data field. So it is searching the data from the 0th address to the next addresses. So in the debugging control, you can observe how the data is changing in these bytes also.
Oh,
Yeah.
gee.
So this will continues. Okay, let me just make it a little bit fast to make it a while. So after the observation, if you look at the data, so it starts at the, all the ASCII values are stored here. For special characters, digits, and special characters, and then the, uh, uh, if you look at here at 65th, that is the 41 location, the character A, the next one is B, the next one is C, next one is D, and it's end with N. So in this activity, what is important means what the importance of this instruction, that storing a byte of data into the memory where the memory address is loaded available in R0 register. The starting memory address is 60. So that's the meaning. So by explaining this at R05 above, that means the value of R03 should be treated as a memory address.